Hi everyone, I'm Anish, the founder of Devoid, and today we'll be continuing with the next episode of DSXAI. Today we have planned with us some problems regarding linked list, and to be very precise, well, this is the previous problem we solved, which is binary search, and the last episode. Today's episode will include reverse linked list. Before you do get deep into this problem, there is some precursor knowledge you guys need to know, and that is about linked lists. Right? It's very important that you guys know that clearly. So the quick summary of linked list, right? It's a type of data structure where, visually speaking, we can think of it like this. Okay, we'll take something like this, 1, 2, 3, okay, and draw some links like this. So these are the links, and it's in a list manner. There's a lot of items. That's what's called as linked list. Very important. And what it does is it has a visual representation in this manner. So the way linked list works is, let's take one item. In an array, when you take one item, right? When you take one item, what does it have? It has the value as well as the index, right? In an array, in a list, previously we already looked into that. In a linked list, what we have is a value and a link. A value and a link. A value, and there's no link here, but it goes to nothing. So that's also a link actually. Got it? It's a null pointer. We'll not go deep into what's happening there. But the point is, every node has a link as well as a value. Whereas in an array, it had index and a value. Interestingly enough, the purposes are a little bit different here. Okay? The link's purpose here is to go to the next node. Whereas in the array, the index purpose is to point the current node. You see? So the purpose also can be different. But the main point is, every item has a link to the next item as well as the value of itself. That is a simple representation of something called as a singly linked list. There are other things. We'll discuss about them as we go further. Of course, if you guys want an exploration time, you guys can just pause it here and take a look into it and go a little bit more deeper into it before getting back into this over here. But for this problem, all we need to know is a singly linked list. And that's what we are diving into right now, a singly linked list right now. Okay? So, what does it have? A value and a link to the next item. So that constitutes a singly linked list. Very important. Okay? So now let's just deep right into the question, dig right into the question and see what happens overall. Question says, given the head of a singly linked list, head, by the way, means the address of the first item. This node is present in some place in the memory, right? Address to that location is the head. Head will say, hey, this is where the first item is. It points towards the head. Points towards the first item, okay, of a linked list. So head, given that first item, our goal is to reverse the list. Now it is the reverse list. What does it mean to reverse the list? Well, you take 1, 2, 3, 4, 5, right? Reversing it just means 5, 4, 3, 2, 1. Or if you want to see in place what's happening, our output will look something like, let's just write 1, 2, 3, 4, 5. But the links are going from forward like this, forwards. It will go from 5 to 4, 4 to 3, 3 to 2, and 2 to 1. Got it? You're just basically swapping all the links in. That's what's required for reversing. Okay? So, of course, visually, it just looks like such a simple thing, swap, alright? It is simple. The code is simple, but you have to understand where every aspect of it comes into play very clearly, because this is one of the core concepts for linked list. Reversing is a very standard thing. So, make sure you pay attention, okay? Now, that's the goal over here. Our head can also be empty. So, that's something we should just be taking into account as well. But yeah, so let's see what we have. I already have the solutions written down so that we can move a little bit faster. And I prepare a little bit more, I guess. That's probably better, right? So I have the solution written down here. But before going into anything else, let's just, like I said, the usual thing, right? So I just want to understand about linked list. No code. Only. Right now, let's not look into the code aspects, but just understand linked list more, right? If you guys want to do it, of course, just write it down and let it know, right? Simple. If you want to be more precise, very important, you can take a look at this. I'm just quickly scrolling through this, right? This is not what we're focusing on right now. If you want to go more deeper into it, take a look at the various things in here. Like, for example, types of linked list. This is very important. Single linked list, doubly linked list, and circular linked list, and whatnot. So take a look at those things if you guys want to go deeper into linked list. At the moment, for our problem, you only need to understand singly linked list. So let's just do that quickly. Can you show some basic code snippets for singly linked list? Okay. So if you see here, you can see it's two parts: data, value, and whatnot. Okay. It's showing in Python itself, so that's good for us to understand. But I explained every node has what? Every item has a data as well as the pointer or something that points to the next item, which we just call it as next for, making sense, right? Next means the next item, simple, next node, right? So we make a custom class to represent this behavior, and then we can initialize and use that class in this manner over here. Okay, got it? This is just some basic code snippets about how to implement a linked list in Python. Okay, and yeah, that is a quick generalization of or a quick summary of things you need to know about linked list. We're not going to go too deep into this right now, but I'm just going to scroll through it and you guys can just take a quick look by pausing the video at any points. But yeah, the main focus is just so that you guys have at least some basics down in the linked list side. Okay. Now let's focus on the problem, which is our focus right now. Our focus is to solve this problem, and how are we going to do this, right? Well, as I just told, there are two aspects. I believe, if I'm not mistaken, we have already looked into stacks. So we can do some things, but we can do, there's two solutions I have in mind. One is using a stack, because stack is very nice for doing reverse of logics. Other one is using some variables to do some pointer logic. Okay. First, let's look into the stack one. Okay. So just imagine this now. Okay. Imagine this. I have 1, 2, 3, 4, 5. And I have access to this one at any point. I can't instantly access 3. I need to go one by one, step by step. Right? So what I'll do is, I'll go to 1. Okay. I'll keep it here in a stack. 1. Next, I'll go to 2. I'll put it right on top of it as 2. Okay. Next, I'll go to 3. I'll add that to the stack. So it'll be 1, 2, 3. After, I'll go to 4 and do the same thing. Then 5, do the same thing until it reaches the end. Done. Now we have something that looks like this. That has 5 at the top, then 5, 4, 3, 2, 1. If we start removing this one by one, what happens? Can you see that? We get 5 out first, then 4, then 3, then 2, then 1, right? Haven't we just already reversed it, interestingly enough? Well, that is actually a visual representation of what we are going to do in stacks. What I'm going to do is going to iterate through the linked list, that is going one by one by one. Okay, like how we are going to one by one, and then store it in a stack so that we keep putting them one above each other, and then remove the last items one by one to get the right order, reverse order. That's it. Simple, right? Well, let's implement this. I have the code ready, so I'm just going to copy paste from here and explain the code. But yeah, just give me one sec. Let me just copy paste right here. Some dot value. Okay. Yep. Okay. Let's just run it once to make sure I have the right code here. And yeah, perfect. Okay. So let's take a look at the code now. Okay. I have the code right here. Let's see what happened in the code and deep dive into it. Okay. So our goal is to reverse the linked list, which means turning it around, right? So what are we doing? We have a stack. We have a current pointer, I would like to call it, because head is also a pointer. What is a pointer? Pointer, essentially, as the name suggests, points to a location. It stores an address that you can use to access a specific memory item, right? It can be anything. Very important. It doesn't have to be numbers only. Don't think it's just numbers. It can be any memory item. So that's the main purpose of pointers. It can point to a location, okay, in the address. Right now, our current is going to store the value of head, which is pointed to the first item currently, okay. So, and then what we'll do is, we'll say while current, that is, while my current pointer is not null. While current means is not equal to null, which means there is some node present. Simple as that, right? If my current is null, let's just show the example. That's better, I guess. So what I'm saying is, while current, and current is a pointer, I told, it's a pointer. So currently, it will point to the first item. Okay. There'll be some address, let's just call it as address 1. And the value of address 1 will be there in current. If current has some value, it means it is true, right? So the loop will continue. Again, current will be some value, some address. Address 2, let's call it. I don't know why I'm writing so badly today. Oh my god. Okay. So address 2. Then finally, let's call it as end of the linked list over here. There's no address 3. So what happens is, we reach a point where current is null. If the current is null, that's considered as a falsy value. So it will be false in the while condition. And it will come out of the loop. That's what's happening here. A simple iteration logic for coming out of the loop when we reach the end of the linked list. And until then, we keep adding one item, one by one by one by one by one. Okay? So we get 1, 2, 3, 4, 5 as 1, 2, 3, 4, 5. That's it. Okay? After that, what's going to happen is, we will take a new variable, okay, that represents the head of the final result that you're looking at. We'll call it as new head. Okay? Why new head? Because, kind of makes sense. New head pointed to the head of the new result that we want, right? And then what we'll do is we'll say new head is equal to stack.pop. What does that mean? What does popping from a stack mean? It means taking the top item. Okay. So we'll take the top item, and then keep it there as the first item. Got it? Then what we'll do, we will say current is equal to new head. Okay. The purpose of this current is to iterate. Okay. CURR variable is only for iteration over here in the loop, so that at every step, okay, you keep having a value popped off. We'll see what's happening this. I'll just copy this code right here, this much, and showcase it one by one over here. Okay. What's happening here? Okay, I don't know why it got pasted like that. Okay. So I hope this is visible. Maybe I can zoom it a little bit more. So yeah, it's like this. Okay. What's happening here? Current is equal to new head. So in our stack, we had 5, 4, 3, 2, 1. Our new head is stack.pop. So it'll have 5 value. So 5 will be there. Then what we'll do? Current, which by the way is 5, currently, dot next. So current ka next link is equal to stack.pop. We already popped 5, so 5 is gone. What's the next item we're popping out? 4 is comes out, right? So we're saying currents next is stack.pop, right? And then we are saying current is equal to current.next, which means current will become this one now. So our new current is this. And then we repeat the process till the stack is empty. That's all you're doing, right? Got it? Repeat the process till the stack is empty. So finally it'll be 5, then it'll be 3, 4, and then it'll be 3, and then it'll be 2, then it'll be 1. When we reach 1, the stack is empty. Okay? So we'll be like, stack is empty, so it goes out of the loop. And then we have not decided what is the next item for this. Right now, we need to make sure it is none specifically. Okay? That's why at the end, we specify it's none, which represents the last ending of the linked list. Because it had a value prior to this, right? You remember 1 had a value? What was the 1's next value prior to this? 1's next value was 1 gives 2. That value was never replaced, right? So the whole purpose of this last step is to replace that value with the null pointer or empty thing. Okay? None, basically. Okay? So we're just going to that and doing this over here pretty much. And if I run this, you can see that, well, it already worked. All right. We can just submit this, and this is one of the solutions. Very important, one of the solutions. Okay. Let's just analyze the solution right now. Let's say our size is n. Let's take an example of n equal to 10. If n equal to 10, how much times do I need to analyze the items? Any idea? I'll have to keep checking every item one by one, at least once, right? Keep checking it one by one. Every item. That's why the time complexity here will be O of n. Okay? Why? Because over here in the while loop, we check every item one by one. Again, we have one more while loop actually. So technically speaking, it's actually 2n. But it's fine. Why is it fine? Because for n equal to, 100,000, right? 2 is a very small number compared to that. And that number changes. So it mainly depends on n. So that's why we call it as O of n. Okay. Finally, we'll have some space complexity also to look into, because we're using something called a stack, which is a variable. Is that space of that stack variable dependent on n? That is, will my stack size be 10, let's say, as a simple example, when my linked list ka size is 10? Well, yes, because we need to store it in one place. That's what we're doing in stack. That is why the time complexity and space complexity both will be O of n over here. Okay. Now, this is fine, but interestingly enough, our next solution does not have space complexity O of n, it has O of 1. Time is still O of n only, but space is O of 1. So it's a little bit better solution, okay? Because it doesn't require extra space. So it's more optimized, better. And that's what we'll look into right now. I have again the answer prepared here. By the way, if you guys don't like this format of me, having the answers prepared and I just want me to type it, you can do that from next class as well. I just am trying something out so that your time is optimized as well, right? I don't want you guys to just listen to me speaking for long times. You guys have to learn a lot. That's the main focus here. Okay, I forgot. I just submitted already, my bad. But main point is, let's take a look at the solution, okay? Now, what happens here? Here, this is again another logic for reverse linked list. Looks quite small, but there's a lot of things happening. It's probably much better if I do a diagram for this one by one and showcase before I explain, or before anything else. So we'll do like this. We copy it here, and then we'll take again a smaller example this time, like 1, 2, 3. Okay, 1, 2, 3. Okay. We will say our current is head. What does that mean? First line, current equal to head means this one. So we'll say this is current because of that first line. After that, also previous is equal to, that's just initialization. we have one thing called previous, which is nothing at the moment. So I'll just keep it as something over here. Okay, empty, nothing. Now what we'll do is we'll say while current exists, that is current is not null, which it isn't in our case right now. I'll say a new variable called next node, we just call it as next for simplicity sakes right now, is equal to current's next. So that's 2, right? Next in the beginning will be 2. So this is the initial setup. Previous, current and next. Okay. Previous, current and next. Okay. Now what do we do? Now what we do is we say current's next item. Okay. Current's next item. We'll just remove this arrow so it doesn't confuse us. Current's next, which is actually 2 right now. This link towards 2 should actually go towards previous, we are saying. So what happens is in the diagrammatic representation, this one gets removed to 2 and goes to previous, which is by the way none. So it's empty. End of this linked list. Okay. That's what's happening in the first step. Not first step, right here. Current.next is equal to previous. That's what this is happening over. Okay. Then what we'll say is previous is equal to current. That doesn't create any links, but it just does this. Our previous now becomes over here. Okay. And the current becomes here. That points towards 2 at the end of the loop. And at the beginning of the loop again, our next will come into picture. That will point towards 3. Then we'll say remove this link current and put it towards previous. We did our connection, right? That we wanted. Then again we say this will become previous and this will become current. Finally, I go to the last one where next actually is none now. Okay. Next is none. Okay. What we'll do now is we'll point this 3 towards 2 and then our current will become next, which is none. When current is none, the while loop is done. And by the way, previous also has moved to here. While loop is done. And my previous at the end of the while loop is interestingly enough pointing towards 3. Our new head. Right? After reversing, it should start from 3 now, from the other end. Right? So with this logic, what's happening? We take previous, current and next 3 pointers that keeps moving one by one in a stepwise manner, iterative manner, to create a swapping of links behavior. Okay? That is the focus of this code base, of this logic, and that is pretty much a quick solution for this. And speed wise, it's still going to be O of n, because time wise is still going to be O of n. Why? Because we're still going through every item, right? We're still doing a while loop that goes through every item in the linked list, which we need to, by the way, because there is no way to not look at the item and still swap it, right? Doesn't make sense. So O of n is time, but space in our case is we are always going to use 3 variables: previous, current, next. That's it. We are never ever dependent on how much variables we use based on the size of the initial input. That is why space is considered as O of 1. That is why this is a better solution. That is, irrespective of how big your input is, you will always use 3 extra memory space. That is very powerful. Okay. Well, and that was pretty much to summarize this solutions. I would again encourage you guys to quickly take a look into other aspects and ask questions with AI, right? To understand more about what you want to, understand in these problems. Reverse linked list is a very standard problem. So I hope you guys really understand what's happening. And yeah, I guess that's pretty much it for this episode of DSXAI, guys. Thank you. One last thing though, before I close off this, is that I understand that some people might not like this format or whatnot and other things, but I really want to improve this and keep building, and I want everyone to grow together. So it would be really helpful for me if Any constructive feedback is given in the chat and comment section down below, right? Anyone who has reached this point in the video, like even saying like it's helped me out, it's good, or even hey, some part of this feels very slow or fast or whatnot. Like I just want to know how my audience is feeling so that I can, see what I can do about it, right? If I don't get any feedback, I won't be able to change things around. I really want to take this forward in a serious manner and make sure that everyone understands what's happening. Also, I'm thinking of planning of some, streams and whatnot, like live streams and whatnot, not just on DSA, because actually DSA is good. It is something I practiced a lot on, but I'm even more stronger in doing like projects, agentic projects and stuff like the agentic AI stuff. So we can see what we can do, right? I just want a feedback from you guys. It'll really help me out all if anyone reached this point. So that's it, I guess. Thanks.